So, good morning, all. Today, we are going to start with the module third, that is IP networking layer. So, that is Internet Protocol layer. So, in this, first we are going to learn the IP addressing. Okay. So, before learning or going to that chapter or module, we have to first know what is IP addressing and what is the classes in that IP addressing. So, this is very important for the general use in your daily life while you are using the internet. Okay, so we are going to study how exactly the internet IP addresses can be formed, okay, and how it can be used and which kind of classes are it has. So let's start. So how we are going to, or which things we are going to learn in this lecture, let's see. So first we will see the internet addressing, then classful IP addressing, classes and blocks. Okay, the masking we will see in the next lecture. Okay, so first we'll go for IP addressing. So what is exactly the meaning of IP addressing? Okay, so suppose you have some name, right? Suppose you have a name that is nothing but your address. Okay, so if I call you by that name, or I ask you to go at or go to this person, means what? Going to, or I'm coming towards particular that person. Likewise, IP addressing is nothing but that is one address assigned to the PC in the internet. Okay, so that is nothing but the logical address. It can be a change. Okay, so the internet assigned number authority is responsible for a global coordination of the internet protocol addressing system. So current there are two types of internet protocol. First is IPv4 and another is a IPv6. That is nothing but IP version 4 and IP version 6. Okay, so IPv4 was initially deployed on 1st January 1983 and it is still most commonly used version. IPv4 addresses are 32 bits number often expressed as a 4 octet in a dotted decimal notation. Okay, suppose you are accessing 192.0 sorry 192.0.2.53. So that is nothing but one IP address, and each process or each uh, the each process is given by the octets. Okay, now there are IPv6 also. So IP addressing v6, it is also developed of the IPv6 protocol began in 1999. So IPv6 addresses are 128-bit number and are conventionally expressed using the hexadecimal string. So now there will be the question in your mind, why we are going IPv4 if you have the IPv, sorry, why we are going to the IPv6 if you are having the IPv4. Now what happened in few countries, not in India but in like Japan or in China or in America, what happened? So this IP address are going to finish, or we cannot say the finish, because they are using the more they are using in many applications. So what happened? So this IPv4 are not that much available, so they are getting in a less quantity. So that's why we are going in a v6 version. Okay, so what is the internet address? So the IPv4 address is a 32-bit address. Okay, so how much there are a 32-bit 32 bits are there in a one address. So IP addresses are unique and universal. Okay, so one IP address cannot be assigned to the another PC. Okay, so the one PC or uh, one thing, or we can say the one element into the network contain only one IP address. So there are two common notations. So first is the binary notation and another is a dotted decimal notation. So in the binary notation, you can see you can simply represent your IP address in a binary form. Okay, so this is nothing but 8 bits, 8 bits. Okay, 8 bits and 8 bits. So total there are 16 bits. Or similarly, you can represent it in a decimal notation also, 128.12.15.10. Okay, was 128.12.15.10. Okay, so this is how you can represent the IP address. So first we'll take one example. Change the following IP address from binary notation to the dotted decimal notation. So they have given one IP address, okay, in a binary form. Okay, and they ask you to convert into the decimal. Okay, so you can simply convert it. So 129, so this is nothing but what, 1009 means that is nothing but 129. Okay, so up to Now this is nothing but what you can convert, that is nothing but 11. So this is 1, 2, 4 and 8. Okay, so these are nothing but 11. So similarly here is also 11 and this is nothing but 239. So we can simply convert the same bit into the decimal form. Okay. Now suppose there is another example, if you have to convert the decimal number into the binary. So we are simply taking the binary of 111, binary of 56, binary of 45 and binary of 78, and simply you can convert the binary form or you can decimal form into the binary form. Okay. So now this is very important, classful IP addressing. There are two IP addressing, classless and classful. So first we'll understand what is exactly the classful IP addressing. So this is very important. So might be in your mind there will be the question. So few IP addresses are starting from 192, few are starting from 10, few are from 128. So it is that? Why there is a difference by starting the every IP address from different numbers? Is there any criteria to decide them, or they are simply randomly it can be decided? No, it cannot be decided randomly. They are decided on their classes. Okay, they are decided on their classes. So which bit or where we can start the IP address? Shall we start from the 10 dot or 192 dot, 168 dot, or whatever? Okay, the starting position of the IP address. That's what we are going to learn, classful IP addressing. So there are actually the five classes of the addresses, IP addresses. So that is named as A, B, C, D and E. So there are five classes of IP addressing. So first you can see here how that can be distinguished, how it can be distinguished. So in a class A, so first we know, first all the binaries, all the IP addressing we are going to learn in the binary form, then and then you will understand exactly the classes. Okay, so first every IP address we are writing into the binary. So first we can see the class A. So first bit is a 0. Okay, in a class A, every time the first bit or you can say the MSB bit is a 0. Okay, so this is nothing but MSB bit is a 0. In a class B, first two bits are 1 0. In class C, there are 1 1 0. In a class T, 1 1 1 0, and in class C, 1 1 1 1. Okay, so this is how we can decide the class A. Then you will feel what is the difference between by changing the one bit to the second bit, third bit, fourth bit, and 4 bit. Okay, so is there any difference? Yes, there is a very big difference. Now I will show you how exactly. Suppose it will start from the 0. So remaining all bits are suppose 1 1 1. Okay, so suppose this is from 0 and this is all bits are 1. So remaining 7 bits are 1, means what? You can identify this is nothing but what? 168, right? So I will tell you exactly what is that. So finding the address classes, how to find the class of that address? So it is a class A, class B, class C or class D. If first bit is 0, okay, if the first bit of the IP address is 0, then it is simply you can call this is a class A IP address. Suppose this is nothing but 0 1 1 1 1 1 2 3 4 5 6, and then 0 1 1 1 0, and then likewise dot, and then next this is first 8 bits, second and third 8 bits, something anything. So you can just simply see the your first 8 bits. Suppose this is the first bit is 0, then you can simply say this is a class A IP address. Suppose first bit is 1 and 0, then you can see this is a class B IP address. Suppose there is a 110, then class C, 1110, that is a class T, and 1111, this is nothing but class E IP address. So very simply to distinguish the IP addresses on their classes. Okay, so we'll take one example, find the class of each address. Okay, so what is the class of address A or first? That is nothing but you can say simply, so first bit is 0, so this is nothing but class A address. Now you can see the B, what is the IP address or what is the class of this IP address? Suppose this is 1 1 1 and 1, so there are 4 ones, so mean this is nothing but class E address. So very simple. I hope you understand what is, how can we distinguish the class of the IP address. Now finding the class in a decimal notation. Okay, so how this is now happen, this is done in the binary, but how you can find into the decimal numbers? So which IP address belong to the which class? So suppose there is a class A. Okay, suppose there is a class A, then your IP addresses start from 0 to 127, right? 0 to 127. Why? Because in a class A, every binary bit, first bit is 0, so remaining all 6 bits are 1. Okay, all 6 bits are 1, means what it makes from 0 to 127. Okay, 0 to 127 in a decimal. You can see this is nothing but 127. So you start from 0, 0, 0, 0, 0, then 0, 0, 0, 0, 1, then 2, 3, 4. Likewise, they will go up to 127. Okay, and then remaining can be anything. Okay, this can be anything. Now the class B. Now class B start from 128 to 191. So this is nothing but start from 1 0. Okay, so every time 1 0, since this 1 will be constant, we can just change the next bit. So it will be nothing but 128 to 191. Next class C, the class C start from 110, means this first two bits are always constant and only changing this last 4 bits, 6 bit, fifth bits. Okay, so we start from 192 to 223. Now class D start from 224 to 220, 224 to 239. So means 1110, and we can change the 1111, and you can change the remaining bits. And now the class C is nothing but first 4 bits we are remaining always constant, and we are just changing the remaining 3 bits, that is nothing but 240 to 255. So total is range from 0 to 255. So there are total 256 bits. Okay, or you can say the 256 levels. So I hope you understand how you exactly distinguish the classes from decimal numbers. Okay, suppose your IP address is represented in the decimal number, how they can be distinguished. Okay, now you can take our example, find the class of which IP address. Now this is nothing but 227. So 227 belong to the class D IP address. 252 it belong to the class E address, and 134 it is belongs to the class B addressing. Okay, so very simple how to identify the IP addresses belong according to the classes. Now net ID and host ID. Okay, so what is this is a net ID and host ID. Suppose our college, okay, our engineering college having the one network. Okay, our engineering college having the one network, and we are assigning the IP addresses to them. These are nothing but the host. Okay, suppose in our college there are 100 PCs, right? In our college there are 100 PCs. So what happened? Suppose I have taken, this is nothing but the, just a minute, this is nothing but the net id. Net id is only one to one network. Suppose you go to the another network, so your net id will be changed. Suppose our college is one network. Okay, our college is one network, then I decide one, suppose I decided net id as a 3. Okay, so 3 decimal number. Okay, so I will take this net id, and this remaining bit 2, bit 3, bit 5, these are nothing but the host id. Means I can use 255, 255 and 255 total number of host. So I can use the that much host IP addresses, or there are, I can use almost the remaining all this nothing but the host IDs. So I can use those that much host into the network. So in a class A there are so many host into the classes, sorry, IP addresses. So there are so many IP address. So means there are almost, how many IP address you can assign? You can assign up to 256 IP addresses in a one network. Okay, so there are, you can see here, so in a one net id, but in a class B there are first 16 bits are nothing but the net id, and remaining are the host id. In a class C you can see there are first 3 bits are nothing but the net id, and there are 256 are the host id. So from this, so the multicast addressing and reserved for a future use. Okay, so this I will explain you later. So now you can focus on a class C only. Okay, you can see focus on a class C. Now you can tell me how many host, or you can say how many PCs can given this IP address, or how or how many IP addresses I can apply in that network. Are you getting my question? What I'm saying? Suppose there is a our engineering college is having the 100 PCs. Okay, our college is having the 100 PCs, and in the class C, how many host IDs? There are only 256 host IDs. So I cannot apply the net ID. I can just apply the host ID. Suppose 0001, 002, 003 up to 0 all 1. So there are almost 256 host, means 256 IP addresses. So I can only use the 256 IP addresses. In that we are leaving the first IP address, that is 000, that is for the gateway purpose, and last one all one, that is nothing but for the broadcast purpose. So there are only 254 hosts. So I can assign only 254 hosts in a class C, right? So in a class B, we can assign 2 raised to 16 IP addresses. Okay, in a in class C we are assigning 2 raised to 8. In class B we are assigning 2 raised to 60, and in class C A we are assigning 2 raised to 24. Okay, so there are almost that much IP addresses. Now you can see, suppose in my network I have only 100 PCs. Okay, what I am saying, keep in mind, if in my network I am having only 100 PCs, then which class I will use? Class A, class B, or class C? Obviously class C, because in the class C there are 256 IP addresses I can assign. Yes, I have 100 IP addresses. I record only 100 IP addresses. So there are, so minimum IP addresses is a class C. So I can use the class C IP address. If I use the class B IP address, then what happen? There are so many IP addresses can be wastage. So 2 raised to 16 IP addresses are there. So I can use only 100, and what about remaining? So they are totally wasted. But if I use the host ID class C and I use 100, so wastage is only 156. Okay, but you can use the class B. There are so many wastage IP addresses. Okay, so I hope you understand what is the net ID and host ID. So in a block in a class C, I will say, so net ID. Okay, so net ID is nothing but the here. So net ID is 0, net to net ID 73. Okay, 0 to 73 and 73 to 127. So there are total IP addresses, and we can assign this to the this network. So there are 73 is the, so 0 to 0 to 55 is a special block that cannot be used for IP addressing. From net ID 73 we can use 73 dot 0 0 0 dot 0 dot 0 to 73 dot 255 dot 255 dot 255. Okay, so that can be used. Okay, so that is nothing but the different, if 1 2 3 4 5 6, you can assign all IP addresses to the networks. Okay, but in the class A there are so many wastage of the IP addresses. Okay, so millions of class A addresses are wasted in class A, right? Because there is only one net ID and all remaining are the host ID. So you can see 2 raised to 24 IP addresses are there. So if you are having the 100 PCs, and why you are going for the 2 raised to 24 IP addresses? So that is, so many IP addresses can be wasted. So mostly this is not a good practice to use the class A IP address. Now we are going to see the class B IP address. In a class B IP address, there is a 128 is nothing but the there is nothing but using for the special purpose. For the application purpose or for general purpose, we are using from 180 to 191. Okay, 180 to 191. So 180.8. Okay, 180.8 and 191 to 255. So you can using those that much IP addresses in a class B. So this is nothing but what, 180.8 is nothing but the network ID, and remaining is the host ID. So last two 16 bit is a host ID, and first 8 bit is a, sorry, first 16 bit is a net ID. Okay, so there are less wastage than class A IP addressing. So there are you will get in one network ID, you will get the 2 raised to 16 IP addresses. Okay, now many class B addresses are wasted similarly, but less than class A. Now the very useful, that is a class blocks in a class C. So we are using from 198 to 200. So there are, in a one network ID there is a 255 IP addresses, or you can say the 256 IP address. So suppose you can take, our college is using 192.0.0. Okay, 192.0.0, that is one network ID our college is using. Then in one network ID there is a 255, or you can say the 256 IP addresses. So in a we can apply the, or you can use the 256 PCs in your college. Suppose you are having the 100 PCs, so, or 200 PCs, so we are simply going for the class C, not going for the class A or B. Or if there is a more than 500 or 1000, then you can definitely go for class B IP addressing, right? So the number of addresses in a class C is smaller than a need of most organization. Okay. Now network addresses, so specific and all zero. So this is nothing but the class A IP addressing. So I have shown here, this is nothing but the class A, this is the class B, and this is class C. In a class A there is 123 is a network ID and remaining is the host ID. In a class B, first 16 bits means 141 to 40 is the network ID and remaining last two for 16 bits is nothing but the host ID. And in a class C, first 3 bits, or first we can say the MSB 24 bits are nothing but the net ID, and remaining last one is the host ID, right? So in a classful addressing, the network addresses is the one that is assigned to the organization. Okay. So given the address 23.56.7 and 91, 23.56.56.7.91, find the network address. So first we have to identify which IP address, this IP addresses belong to the which class. So we know that this IP address belong to the class A. So in, in the class A there is a net ID is the first 8 bits and remaining is the host ID. So you can see here the 23 is the network ID. Okay, this 23 is the network ID and remaining is the host ID. Okay. So given the address, find the network address. Okay, so in 132 belongs to the class B, right? So 32.16 nothing but what? Network ID. Okay, and 70.85 is nothing but what? Is nothing but the host ID. So the default mask in the binary, you can see A, B and C. These are nothing but the default mask. Okay. Okay, that I will explain you in the next lecture. What is this mask and default mask? This masking is another concept. Okay, so thank you very much for today's lecture. I hope you understand the things. If you don't understand, you can simply message me or call me, so I will explain you again. So thank you very much for today's lecture.